The objective of this video is to learn how to add and subtract numbers in scientific notation. Okay, so we were given a problem like, if we're given a problem like this, and we are asked to solve this, in the past you would have done something like this, maybe line them up vertically. I know I like to line them up vertically. And then you would, making sure that the 6 and the 2 lined up because they're the 1's place value. The 5 and the 3 were lined up because they're in the 10's place value. So you lined up those like place values to add them. And 2 plus 6 would give you the 8. 5 plus 3 would give you 8. Bring down the 3, bring down the 5. You'd end up with 5,388. And when you did this, you would not do something like this. You'd want to, if they were lined it up like this, you'd be adding what is essentially a 30 into the 5,000 time frame here. So you'd be adding 3,000 to 5,000 rather than adding 30 to 50, which would make this answer completely wrong. This is just no good. You don't want to do that. What you want to do is when you're adding or subtracting, you have to line up your numbers so you're adding or subtracting, or adding to or subtracting from like place values. And we're going to be doing the same thing when we do this with scientific notation. Okay, so let's say we are given 5 times 10 to the third plus 6 times 10 to the 2. Now, you might be tempted to do something like adding the 5 plus 6, but when you do that, what kind of times 10 to the what are you going to have on there? Who knows? Is it the 2? Is it the 3? And then you're going to end up with this 11 here. What do you do with 11? It doesn't make much sense. So let's look at it as if we were to expand out the problem. If we were to take 5 to the times 10 to the 3, that's 5,000. 6 times 10 to the 2, that is 600. Take these two and add them together. We add them together like this. You're going to get 0, 0, 6, 5. So that's 5,600. And that makes sense. Now, to convert that back to scientific, we would move the decimal over 1, 2, 3 place values. So we would end up with 5.6 times 10 to the 3. Now, the question becomes, how do we get from this to this without having to convert to the standard form? It may be easy when you've got exponents of 3 and 2, but when you've got an exponent of, let's say, 31 and 25, do you really want to be putting all those zeros out there? I don't think so. So we want to find some way to get from here to here without doing this. And to do that, we're going to be working with some basic steps. The basic steps are make the exponents the same. Because just like when you're working with fractions, when you add and subtract fractions, you have to have a common denominator. When you're adding and subtracting scientific notation, you have to have the exponents the same. Once you've done that, you can add and subtract the first factors. If you're adding problem, you would add, subtracting problem, you would subtract those first factors. Then you would put a times 10 to the common exponent on the result and adjust the answer as necessary. Let's take a look at this one in a little more detail. Okay, so the first basic step was to make the exponents the same. And you've got to break that down a little bit. The first thing I would do is choose which of these two exponents I want to have as the common exponent. My strong suggestion is always to use the larger exponent. But I'm going to do this two ways. One way is going to be using the larger exponent on this side. This side I'll use the smaller exponent. By doing it this way, hopefully you'll see that using the larger exponent will be simpler in the end than it would be to use a smaller exponent. You'll also get a chance to see the process of how to add or subtract the numbers. Okay, let's move this out of the way. Bring up this. Okay, we're going to add to, subtract from, add to if you're adding, subtract from the other exponent to make it equal to the one you have chosen. All right, so on this side, since I chose the 6, I'm going to add 2 to the 4 in order to make it a 6. On this side, since I chose the 4, I would subtract 2 from the 6 to make it into a 4. And for every 1 you add to the exponent, move the decimal 1 place value to the left. Okay, so I've added 2, so I'm going to move this 1, 2 place values to the left. If I subtracted 2 from the exponent like I did over on this side, I'm going to move the place value on that, the decimal place value, 2 places to the right. Okay, so after having adjusted this number, this scientific number here, to be a non-scientific, but to have a times 10 to the 6, and adjusted this number on this side to have a times 10 to the 4, no longer in scientific, because this number is greater than 10. This one's not, because this one's less than 1. All right. But now we have the same exponents in both problems there, which means that we can actually work with these first factors to do the work. Okay, so at this point we have adjusted the numbers to have the common exponent. So let's take this set of instructions away. The next part we're going to be adding or subtracting, since we are talking about a subtraction problem here. So the subtraction problem, we are going to be subtracting these first factors. I'm making sure we line up the decimals when we add or subtract. All right, so to do that, I'm going to do 4.00 minus 0.08. Borrow as needed. 10 minus 8 is 2. 9, 3. Bring down the decimal. This is my first factor. So on this side, I'm getting 3.92. And this is where we would say we add the times 10 to the common exponent. So we're going to have a times, move to the left, times 10 to the common exponent of 6. And this one, we have reached the final answer. Because this number is in scientific notation, the number in front is between 1 and 10. We have a times 10 to the 6. We have done our subtraction. That is the final answer. Okay, now over on this side, we're going to work with the same thing, but we're going to do the 400 minus 8. Again, we do the 3, the 10, the 9. We have 10 minus 8 is 2. 9, 392. Now at this point over here, I end up with 392 times 10 to the 4. Now this is why I like working with the larger exponent better. When you work with a larger exponent, no need to simplify. But when I'm working with a smaller exponent here, you'll notice that this number is much greater than 10. So I have to adjust it by moving the decimal over 2 place values, giving me the 3.92. If I make this 2 smaller, I need to make the exponent 2 larger. So I'm going to end up with times 10 to the 6. Still end up getting the same answer at the end, but you had to do this adjusting partway through. So hopefully you can see working with the larger exponent will generally make it so you won't have to adjust much at the end. Okay, here let's work through some examples without all those rules off to the side. All right, so to do this, I'm going to work with the times 10 to the 5th here. So that means I need to add 1 to this exponent, which means I need to make the first factor 1 smaller. So I end up with 4.5 plus the 0.32. Put a placeholder 0 in here. I get 4.82. So you're going to have 4.82 times 10 to the common exponent of 5. And there's my final answer. Here, I would add 2 to this exponent, making this 2 place value smaller to make both of these exponents into a 4. So I end up getting 4.6 plus 0.051. Put a couple of placeholder zeros in there. You end up getting 4.651 times 10 to the 4. And just to show you the typed up so it's not as messy as my handwriting, there are the answers with a typed up version. And don't forget, you should always box or circle your final answer. So either box or circling that one or this one, the typed up version. Those are your answers.